Okay, so what you have to know when you are given an exponential either growth or decay kind of equation, they all follow the same formula. And that formula is A equals CE to the KT. They all will follow this. In this, these variables all mean something different. So A is the amount after T years or hours, whatever it's measured in. C is the initial amount. T is time. And K is called our constant of variation. So this K value right here dictates how quickly or slowly my model is growing or getting smaller. This is typically the value that you're going to have to solve for. In some formulas, that could also be an R, because that could be the percentage or rate at which I'm increasing or decreasing. So I believe we did look at a story problem about money compounding in an account. The K and the R are the same thing.
So what is the E?
E is the E base that you have on your calculator that we've been dealing with.
Oh.
Yeah. So what we're going to do is we're going to use this equation to solve this problem. I know we're all so excited. So in the end, it's asking us to identify the age of a mummy that only has 30% of the carbon-14 left in their body. I can only solve for this if I know what my K constant is, and I don't know what my K constant is, so that's the first thing I'm going to have to solve for. In order to solve for that, I need to use information that I've been given. What other information was I given about the carbon-14 organism, material, whatever it is? What do I know about it?
Half its life.
It's half of its life is 5,730 years, right? So I'm going to use that to solve for K. So let's say that initially I start with C amount of carbon-14 in somebody's body, right? What's half of C? Just 1/2 times C. I don't know what it is. So that's the A amount I'm going to be plugging in because I know that this is going to be equal to half of whatever I started with. And then the time is going to be that half-life number of years. So A was just half of what I started with, and T was 5,730. Now we're just going to move some stuff around to get the K value by itself, and then we'll plug it back in and solve for my mummy problem.
Wait, I've got a question.
Yes, what's your question?
You multiply 5,730, so you don't have to put that in front of C.
Say that again.
Could you multiply 5,730?
Not going to do anything. No. If it was an amount, like if I knew I started with 5,730 units of it, then I could do that. But that's time, not amount. Okay, so my goal here is to solve for K, so I need to get that E to the power term by itself. What's the first thing I'm going to have to move? The C. I need to get rid of that C right here. What am I going to do to get rid of it? I'm going to divide it from both sides. When I do that, C's over here cancel and C's over here cancel. So I'm left with 1/2 equals E to the 5,730 K power.
You have to put K.
Yes, the K is what we're solving for, so it has to be there. My goal is to solve for K. So somehow I need to bring that 5,730 K down from the exponent to the main level. I know how to do that. We did it yesterday. Somehow I need to cancel out that E base. What's the only thing that does that? Natural log. So what I'm going to do is I'm going to take the natural log of both sides of this equal sign. So I'm going to have the natural log of 1/2 equals the natural log of E to the 5,730 K. On this side, natural log and E are going to cancel. I'm going to rewrite 1/2 as a decimal just so I don't get confused. And that's going to equal the 5,730K. Are we all okay with what we did there? So now to solve for K, what am I going to do next? Divide by the 5,730. So we just manipulated this equation and figured out that my constant of variation K is equal to the natural log of 1/2 divided by 5,730. That is really, really ugly for me to keep like that. So I'm going to change it to a decimal using my calculator. So everybody plug natural log of 1/2 divided by 5,730 into your calculator. And we're going to take it to at least 4 decimal places depending on what the number is. It's very small, so we're actually going to use 6 decimal places for this number. It is a negative. So when I plug all of that into my calculator, I should get negative 0.000121. Do you see why I chose not to do 4 decimal places for this? It would have been mostly zeros, and while that's helpful, it doesn't really give me an exact value, so I wanted to go a little farther. Are we all okay with getting that? Anybody confused? So now what we're going to do is we're going to rewrite our generic equation, and we're going to put that value in for K. So now my equation for this particular problem is equal to A equals C E to the negative times T. So I just input that value for my K, because that is what my constant of variation is. And now I get to solve the problem that this was actually asking me to solve. And that is what?
The amount of carbon-14 left.
Nope. How old is a mummy that has 30% of its carbon-14 left? So we're going to solve it the exact same way, except this time we're going to be solving for T, because I need to know how old it is. So if I'm starting with C amount of carbon-14 in the body, what is 30% of that? 0.3 times C, yes. So A is going to become 0.3 times C because that's the same as 30%. I'm going to continue just like I did before. We're going to divide both sides by C. When I do, I get 0.3 equals E to this super fun decimal.
Why did A become C?
Because C is what I'm starting with, so 30% of C is 0.3 times C. It became the 0.3 times C.
Okay.
A is just whatever amount is left.
Okay.
So now what's my goal? To get T by itself. What am I going to have to do to get T by itself? Why natural log? Who said it? Why natural log, Madison? I have to get rid of that E so the exponent drops to the main level of the problem. So I know that the natural log on the right is going to cancel the E, so I'm not going to write it. Because once you learn these shortcuts, you don't have to show every single step happening. So what's happening is I have natural log of 0.3 equals, the E is going to go away with the natural log, and I just have the negative decimal T. Right? We're all kind of okay with that. Miranda, what am I going to do next? Divide by what? Yep, I'm gonna divide that ugly decimal in front of my t out from both sides to get the t by itself, and then I can just plug it into my calculator. So then I get that t is equal to the natural log of 0.3 divided by that decimal. And we get the answer 9,950.188 years. That's what you should get. Anybody else getting this answer? Okay, some of you, good. Does this answer make sense in comparison to the half-life years that I've been given? Right, because half-life is 5,000 some years, and 30% is less than half, so I expected it to be longer than 5,000 years. So it sometimes helps to think about this in the context of the problem. If I had gotten like 1,000 years, I know I would have messed up somewhere because it wouldn't fit with the context of the problem, the other information that I'd been given. I will tell you, I think this is probably the hardest type of problem that you can get, and I believe the ones on the homework are a little bit easier. Does this kind of make sense seeing it in front of you? Kind of. I will be much nicer on the test if I give you one like this. Much nicer. Okay, so we have one more. And I honestly think it's easier than this one was. It is a little bit longer, but it is easier. What?
Good thing we have computers. I missed a page. I'm writing this page.
So this is problem 2. On the bottom, that is 1 plus 2e to the negative 0.12t. Yes. So this problem says that the population of a herd of deer can be modeled by the equation P of t, where t represents the number of years since the Park Service has been tracking that herd of deer. Well, I'll tell you in a second. This is just information. I just want everybody to get it written down. I will tell you that if it gives you an equation, that's the one you're going to use. If it doesn't, then we use the one that we wrote down on the previous problem. So this actually has 3 parts to it. Part A is asking us to evaluate P of 0 and interpret its meaning in the context of the problem.
that if I could.
I don't know, I kinda like writing it
They say you remember things better if you write it and see it and hear it.
out. Well, last year, whenever I went off, we were writing it, and then I got switched to home, and she started printing out.
Yeah.
It's just easier for me to like write.
Okay, Megan, since you're already talking, let's share what we're gonna do first. What is the first part of part A asking me to do?
What it says
Yeah, what does it say?
to evaluate
Right, so that is literally the first thing I'm gonna do. What does evaluate mean?
Check out.
To find or to solve or to plug in. So what this means is I want to take that P of T equation that I wrote, and where the T is, I'm going to put a 0 and I'm going to solve it out. So the first thing I'm going to do is write that P equation, substituting 0 in for T. Which leaves me with 1200 over 1 plus 2e to the power of negative 0.12 times 0. Then I just start to simplify it. What's negative 0.12 times 0? 0. So then this becomes 1200 over 1 plus 2e to the 0 power. What's e to the 0 power?
1.
1. What's 1 times 2? 2. So then that becomes 1200 over 1 plus 2. What's 1 plus 2? 3. And then I do 1200 divided by 3. And you get what? 400. So when we're looking at story problems, I expect you to use units and labels when applicable. So what is that 400 representing?
Wait, I got
The number of, nope, give it a second. What's that?
what happened to E?
The e to the 0 becomes 1.
So we just won that.
Well, 2 times 1 is just 2.
Oh.
So I didn't write it here. Yeah. What?
Population.
Population of deer. So this should be 400 deer. But it's the population of deer when? At the beginning of what? At the beginning of time? At the beginning of when the park opened? Since the Park Service started tracking them. So that means in the context of this problem, there were 400 deer when the Park Service started tracking them. So that's what I want you to write. So you can just put 400 deer when and then explain what that means. Your answer is no good to me if you don't understand what it's telling you.
Are we have to explain or?
If I ask you to justify, then yes. You never know. Never know. Okay, questions, concerns, or issues with that part? Does that make sense to everybody?
That's only part.
That was part A. We have 2 parts to go. Part B. Asks us to use this function to predict the deer population after 4 years. And we're going to round to the nearest whole number because we can't have half of a deer. Okay. We do not count partial deer.
What about little deer?
They're still deer.
Dwarf deer.
They're still deer. It still counts as one whole living being.
What if it has two heads? It's just a two.
I'm not real sure, okay? Oh goodness, okay. So this says to use the function to predict the deer population after 4 years. So who thinks they have an idea of how we're gonna do that?
Multiply by 4.
No, definitely not multiply it by 4. I think I heard Matt said. In for the what? Plug 4 in for T because I'm asking what's the population after 4 years. That's exactly what we're gonna do. So I'm going to take that P function and I'm gonna put 4 in for T. So then that's going to become 1200 over 1 plus 2 e to the negative 0.12 times 4. And if you want to, you can just plug that whole thing into your calculator. Just make sure you're very, very careful about how you're doing it. I will say if you're plugging it all in at once, be sure you put parentheses at the beginning of that denominator, because that's the number one mistake you guys see happen when somebody tries to plug something like this into the calculator. And when you think you have an answer, raise your hand. I want to see what we come up with. Keaton, what'd you get?
698.9.
Perfect. So just take a second to practice plugging it in until you get it to work and then see what you did differently. Also, if you got it to work with somebody sitting next to you didn't, please work with them. Oh my goodness. I'm coming. See it. Both of you. Okay, that works. Divided by. You forgot the 2 in front of the E. You forgot the 2 in front of the E.
I got 536. Yeah, I got 536 again.
I got like 8. That's
Yeah,
not
this
right.
E was wrong.
I'm just so long.
I didn't put the E in.
Wait, what did we do?
Keaton didn't plug the E in.
No,
I said Keaton got the wrong answer.
Now I got what she got. What did you do?
Okay, I might have messed up. Who knows?
I said Keaton was wrong.
Yeah, no. Yes, I got. This is what I.
You never know. Nobody's perfect.
I got all wrong because everyone else is doing what I got.
I'm still getting the 536, so that might be
I'm
it.
not even getting that.
No.
Please.
Yeah, I got the 5 as well.
Did you get that?
I still got
What did you get? 8?
I wish it.
Oh, I
didn't divide. Oh, I forgot that.
We're just gonna say that it should actually be 536. Apparently, I was too hasty when I was plugging it into the calculator.
I bet you forgot the E.
536 point what?
2968.
Okay.
296.
Yes, I just want the decimal so we can practice it and then we'll do that. I must have gotten a lot hasty.
I still got.
And you can't round up
I still
like this because you can't have.
It says round to the nearest whole number, so we're just approximating.
536.
Okay.
Here.
Is everybody getting 536? Okay. Yeah. Okay. If you got it, but the person next to you didn't, please check with them.
Oh, I'm filling it up with 5,000.
I got it. Sorry, I stole it.
Should be one. Who else is not getting it?
Did you
You got it? Yes.
I don't know.
You put parentheses and negative 0.12.
Give me a second. Oh, they're so. Math takes me a minute. Okay, so these here.
No.
I know, I was joking.
Oh, hell. Wait, what's this?
Oh, I got it.
You got it? I see. Oh.
Oh, yeah. This is public. I can form equations, not sentences. Okay, did we all get this to work out? No? Oh. Oh, I do. You need to put the times 4 in the same parentheses that we said negative 1. Okay, we are almost done. Can we please finish?
No.
Yes, awesome. Did it ask me for the exact value or did it ask me to round?
Approximately.
Round to the nearest whole deer. So am I going to round up or down on this one?
Down.
Down. So this is approximately 536 deer present. No, deer is plural for deer. After 4 years.
People say round down because I'm like, I think they're like, we're gonna go down a number.
So that's the whole thing. No, that's just a deal.
When she said round down, I got puzzled.
Do we all see why we rounded down?
Yeah, but I just don't like when they say round down, because like, it stayed the same. You're not going down.
They stopped saying round down in like 3rd grade because too many of us were confused. Oh, rounding down.
Like, we would literally be like, 535.
Okay, do we feel okay with that one? Yes, maybe? We have one more part to go and then we are finished.
I think I'm feeling okay.
So this is part C. But they all have A, B, and C. Not all of them. I don't think they all do anyway.
So we're gonna have 15 problems.
We have to do a whole age snack packet for home.
Yeah.
Wait, no, like, no, I was like, oh,
I don't remember any.
no.
You know what I miss in elementary school where we had the 100 facts?
Yeah, that was.
I don't know my homework class. I didn't look at the classes.
Okay, part C asks us to determine the number of years required for the deer population to reach 900 and then to round our answer to the nearest year. So before, if we wanted the population at a specific year, we just plugged that year in, correct? What do we do if we're trying to figure out the number of years, but we know the population?
What's the population? And solve for.
Am I plugging that population in, or am I setting it equal to that population?
That's what you said.
That one. So So this is going to become 900 equals 1200 over 1 plus 2e to the negative 0.12 t.
I hate writing.
So now I have the population and I'm going to solve for the number of years t. Paige, where am I going to start? What? Okay, what's the first thing we really don't like about this problem? Can you say that again? It's dividing. There's a fraction, so I have a denominator. That's actually really, really messing with me. So what I want to do is I actually want to do something that's going to move that denominator up to the same level as the rest of the problem, so I don't have to deal with it. So what I'm going to do is I'm going to take this whole denominator and I'm going to multiply it over with the 900, but I'm not going to distribute the 900. You can if you want to, but I'm going to choose not to. Actually, no, it might actually be easier to do that. Let's distribute the 900. I think it's going to be better. So we're going to multiply that over. It's going to become 900 times 1 plus 2e to the negative 0.12t equals 1200. I'm going to distribute the 900 into that. It all will go in the calculator, yes. So all I did was then multiply the 900 into the 1 and into the 2, and that's it. It didn't have to go into anything else.
Wait, why doesn't it go into the?
Because this is all one term, so it only has to go into each term one time. Because it's connected by multiplication.
Oh, because the 2 is gonna.
Yeah. Yes, Madison.
So you basically just cross multiply?
I basically just cross multiplied, yep. And now what I'm going to do is I'm going to move some stuff around and isolate the term that has the t in it. So what's the first thing that I'm going to move? The 900. What am I going to do with it? Subtract it over. When I do, I get 1800 e to the negative 0.12t equals 300, because 1200 minus 900 is 300. Then divide by what, Jalen? The 1,800 needs to be divided out of both sides. These are going to cancel, and I'm just going to have e to the negative 0.12t equals, this will simplify into 1 over 6. And then do what? Why am I hearing natural log?
Because you have to rid of E.
Because I have to cancel out that e. Perfect. I'm going to do that to both sides. I know this one's going to cancel. So it's just going to be negative 0.12t equals the natural log of 1/6. And then I'm going to do what? Divide by the negative 0.12. And then I can just put it into my calculator. So t is going to equal the natural log of 1/6, all divided by negative 0.12. I want the decimal first, and then we will round. Yeah. I got 14.9 when I did it. But now I don't trust myself. So I don't. Okay. So it seems like we should be getting 14.9, but it said to round. So am I going to round up or down? Up to, so we say this approximately 15 years for the population to hit 900.
See, that doesn't seem right at all.
Wouldn't it be a negative?
No.
Oh, it's L and
Because the natural log of 1/6 is gonna be negative, and a negative divided by negative is gonna cancel. It's gonna be positive. Natural log of 1/6, yes. It will be a negative number.
So that doesn't make any sense because after, what was it, 4 years, it was 536. Oh wait, that's because it only went up 136. Okay, no, I see it now.
And it might grow really quickly for the first couple of years and slow down after that. That happens too. Or it might go really, really slow and then shoot up. It just depends. Okay, your homework is on Canvas. It is, I think, 3 or 4 on your homework. No, it's definitely more than that, but I think it's only like 3. I think it's 3. 15, 5 minutes.
5 minutes.